Salam and welcome everyone. So today we're going to be working on the question on the screen that says in an industrial process, nitrogen is heated to 500 kelvins at constant volume of 1.000 meter cube. Full stop. The mass of the gas is 92.4 kilograms. Use the van der Waals equation to determine the approximate pressure of the gas at its working temperature of 500 Kelvin. For nitrogen, the van der Waals parameters A is equal to 1.352 decimeter is to the power of 6 atmosphere per mole squared, and the van der Waals parameters B is equal to 0.0387 decimeter cube per mole. So in this particular question, we're asked to determine the approximate pressure. Okay, we're asked to determine the approximate pressure in the using the van der Waals equations of state. But before we can go ahead and do that, we have to first of all write out all of the parameters that we're given. We've been given the value for A, we've been given the value for B. We've been given the value for volume, which is just 1.000 meter cubed. And of course, the value for temperature to be 500 Kelvin. We've also been given the mass of the gas to be 92.4 kilogram. Now, we have all the information that we've written down all of the information that we've been given, but then there's an issue. We have to first of all realize that we're dealing with the van der Waals equation question. So we have to write out the van der Waals equation of state, which is pressure is equal to RT divided by the molar volume minus B, so minus the parameter B, minus the van der Waals parameters A divided by the molar volume squared. Looking at this, we see that we know R because R is just simply gas constant, so it's a constant value. We know temperature, we know B, we know A, but we have volume, and so we have molar volume and then molar volume squared. But then what we're given in the question is just simply volume. We actually don't have molar volume. And for those of you who don't know, molar volume is simply the volume divided by the number of moles. So as you can see, we're not given the number of moles, but we're given the mass of the gas. So when you have the mass and you know the identity of the gas, in this case is nitrogen, we can determine the number of moles by using the molar mass and the value for the mass. So the number of moles is just simply going to be mass divided by what? Molar mass. So the number of moles here is just going to be the mass is 92.4 kilogram, but because of mass in chemistry, we prefer it to be in grams. We're just going to convert 92.4 kilograms to grams, which is just simply 92.4 times 10 raised to the power of 3 grams. And of course, the molar mass of nitrogen, we know that to simply be, well, just N2 gas. So the molar mass for N2 gas, nitrogen gas, is 28.014 gram per mole. So of course we can cancel out the grams, 92.4 times 10 raised to the power of 3 divided by 28.014 gram per mole. So the number of moles is just simply going to be this information, the numerator divided by the denominator. And when we do that, we end up getting 3,298.351 mole. So that is basically the answer to this. But let's not forget that we're not just simply to determine the number of moles. What we're actually using the number of moles for is for us to determine the molar volume. So the molar volume here is just going to be the volume divided by number of moles. So molar volume is just going to be, the volume here is 1.000 meter cube. Wow. Well, let's not forget that the value for A and the value of B that we're given in this question is in decimeter, right? And then we have the volume in meter cube. Now we have to do an extra work, which is for us to convert from meter cube to decimeter cube, because we want to have all our numerical values in the same unit, so it's easy for us to solve the question. So our work is not quite done. Like, I'm sure you guys were thinking, oh, we can just simply divide, but that's one thing with chemistry. You have to make sure, or science, honestly, you have to make sure that all of the units match. So going from meter cube to decimeter cube is what we're going to have to do here. So now going from meter cube to decimeter cube, we have to first of all not forget what 1 meter equals in terms of decimeter. So 1 meter is always equal to 10 decimeter, and that is just the value for length. Now we're dealing with volume, so we can just simply cube it, right? Because we're dealing with area, we're going to square it. So you cube it here, so you end up with 1 meter all cube is the same thing as 1 times 1 times 1, that's 1 meter times meter times meter, that's meter cube. And then 10 decimeter all cube is the same thing as 10 times 10 times 10, which is just 1,000 decimeter times decimeter times decimeter, decimeter cube. So that is basically it. Now, yeah, that's it. That's we've done the proper conversion. So what we end up having here is just simply 1,000 decimeter cube. So going back here, the molar volume is just simply going to be 1,000 decimeter cube divided by the number of moles, which is just simply 3,298.351 mole. Of course, you put this information in your calculator, the molar volume becomes 0.30318 decimeter cube per mole. So that is the molar volume. So we go back to our work again, and we see that the time we see from our what's it called, our van der Waals equation of state, that we have all the parameters that we need in order for us to determine pressure. We have the gas constant, we have the temperature, the value for A, the value for B, and of course the molar volume. So yeah, now we can just simply substitute. So yeah, we can simply substitute. So I'm going to do it at the bottom here. So pressure is going to equal, again, RT divided by the molar volume minus B minus A divided by molar volume squared. So to do that, we have pressure is just simply RTR is 0.08206 dm cube atmosphere per mole Kelvin times the value for temperature. We have temperature here to be 500 Kelvin. So 500 Kelvin divided by the molar volume, which we know to be 0.30318 decimeter cube per mole, okay, minus B. And of course, B is simply 0.0387. So 0.0387 decimeter cube per mole. So that's it. So all of that minus, and then you have A. What is A? We substitute A. We know A to be 1.352. So minus 1.352 atmosphere dm6 per mole squared divided by the molar volume squared, which is just simply 0.30318 decimeter cube per mole all squared. So yeah, that's basically how it's done. So now, of course, let's cancel out Kelvin, cancel out the Kelvin. Yeah, we've canceled out all of that. We can now continue with our math. So 0.08206 times 500 is simply 41.03 decimeter cube atmosphere per mole, okay, divided by 0.0 divided by 0.30318 minus 0.0387 is just simply going to give you 0.26448 decimeter cube per mole, minus 1.352 atmosphere decimeter raised to the power 6 per mole squared divided by per mole squared divided by 0.30318 decimeter cube per mole all squared. That's simply just going to be 0.091918 decimeter raised to the power 6 per mole squared. So yeah, that's how it's done. Cancel out decimeter cube, cancel out decimeter cube, cancel out mole, cancel out mole, cancel out decimeter raised to the power 6, decimeter raised to the power 6 divided by mole squared, and then mole squared. Yeah, so you've canceled out all of the units, only the unit that you need, which is just atmosphere, because we're actually solving for pressure. So that just makes sense. So 41.03 divided by 0.26448 is simply 155.1346 atmosphere minus 1.352 divided by 0.091918, which is just simply 14.0 7087 atmosphere. So of course, you solve this, pressure ends up being 155.1346 minus 14.7087. You end up getting 140.42584 atmosphere. And of course, because we are chemists, scientists, we have to put it in the lowest number of significant figures based on the values that were given at the beginning of the question. So the lowest number of significant figures, we have 500 in 3 sig figs, 1.000 meter cube in 4 sig figs, this one in 3 sig figs. So our final answer has to be in 3 sig figs. So it's going to stop here. So the value for pressure is going to be approximately 140 atmosphere. So this is the answer to this question. So yeah, that's basically the answer. If you have any questions, please put in the comment section. If you have any suggestions or concerns, also put in the comment section. If you're a student who is struggling or trying to improve in all your STEM related courses, whether you're in middle school, high school, or college level, just make sure you email me at shuhabi@gmail.com. I help students succeed and be the best version of themselves, as well as assist them navigate their academic life. So if you would need my services, email me at shuhabi@gmail.com. Also, make sure you click into the description box. I have done a bunch of these physical chemistry questions from the physical chemistry Atkins 11th edition. So the playlist in the description is going to be of use to you, as well as if you'd want to purchase this book, click on the link below. The book we're using again is Physical Chemistry 11th edition, the Atkins Physical Chemistry 11th edition. Don't forget to like and subscribe. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.